the James Webb Telescope has essentially revealed the clearest picture of Proxima B in history, uncovering stunning bits of knowledge into a possibly tenable exoplanet. It obliges us as we set out on an excursion through space to uncover the insider facts of Proxima B and find out whether it could be the next Earth. We ought to take off into the vast expanse of space where a mysterious planet exists in the habitable zone of its star Proxima Centauri. This planet is not just any ordinary rock, its reality. See, Proxima B is found a mere 42 light years from us. This planet is covered in mysteries and wonders. Could it be another Earth with seas and life blossoming on its surface? Anyway, wait. There's more. Proxima Centauri B isn't alone in that system around the red dwarf star. It has a companion, Proxima Centauri C, and who knows what other mysteries the star system holds. Maybe there's another companion that we haven't yet discovered. The secret doesn't stop there. Proxima Centauri produces roughly the same amount of energy from its star as Earth does from the Sun. Could this truly mean that there's water on its surface and perhaps even life as we explore beyond our own solar system? We encounter an entirely new universe of exoplanets, planets that orbit stars other than the Sun. With 200 billion stars in the universe, the opportunities for exoplanets are endless. Some exoplanets even wander freely, untethered to any star, like wandering travelers in space. Among them all, Proxima Centauri B stands out as an especially striking and captivating planet with a year that lasts only 112 Earth days and a distance from its star that is generally closer than Earth is to the Sun. Indeed, one side of the planet is constantly washed in sunlight while the opposite side remains in everlasting darkness. Now let's examine Proxima Centauri, the star that Proxima B orbits. Proxima Centauri is part of the Alpha Centauri triple star system. This system includes real Chorus, also known as Alpha Centauri A and Alpha Centauri B together. These stars form the closest star system to our solar system. The two stars real Chorus and Alpha Centauri B form a binary system known as Alpha Centauri A and B. These G and K type stars appear as one star in the constellation Centaurus and are the third bright stars in our night sky, with a peak luminosity of under 2.7. Proxima Centauri, also called Alpha Centauri Ca, is a red dwarf or M-type star found 21 light-years from the other two stars, typically about 4 times the distance between Earth and the Sun. It is the closest star to us. Proxima, in fact, means the closest star in Latin, and it was discovered in 1915 by Scottish astronomer Robert Thorburn. Despite being our closest celestial neighbor, it is not visible to the naked eye, having an apparent magnitude of 11.13, which is much fainter than the human eye's limit of 6.5. Anyway, don't let that fool you. Proxima Centauri is still a star worth studying. Red dwarfs like Proxima Centauri are among the most efficient in terms of energy production. They may not produce a lot of energy, but the internal convection processes at their cores keep them shining for trillions of years. Generally speaking, Proxima Centauri will remain a main sequence star for another 4 trillion years. However, the habitability of a red dwarf star like Proxima Centauri is still debated. For one, it's a flare star, meaning it has frequent and intense explosions. As a low-mass star, its habitable zone would be much closer to it than the Sun's projected to be, somewhere in the range of 0.23 to 54 cents, but it's not as habitable as it seems. Proxima B is bombarded by intense ultraviolet radiation from its star, regularly stronger than the radiation we get from our Sun. That's right, it's so extreme that even the lightest particles of hydrogen are stripped away along with nitrogen and oxygen. But that's not all. Just because a planet is at the right distance from its star doesn't mean it can support life. Proxima B may not have a stable atmosphere, which is essential for regulating temperature and keeping a water-friendly surface. Without it, living creatures would be vulnerable to harsh space weather conditions, making life nearly impossible. So while Proxima B might appear Earth-like on the surface, it is far from being able to support life. Scientists remain somewhat cautious, as there are many factors that render it inhospitable. The mission to reveal the truth about Proxima B continues, and some still hold hope. One tool that has garnered the attention of astronomers is the James Webb Telescope. After years of anticipation, the telescope was finally launched in 2018 and will help us determine if there is life on Proxima B. However, as with everything in science, things are never as clear as they seem. Several adjustments were needed to ensure the James Webb Telescope delivers accurate images. As Habitable, a theoretical physicist at Harvard, explains, if a planet like Proxima B can absorb light from its star, it can also emit it as infrared light. The James Webb Telescope was specifically designed to detect infrared light. It can capture images of this light from the planet's surface and search for patterns that could confirm the presence of water or an atmosphere. But what if the planet has an atmosphere that's not conducive to life? The presence of an atmosphere doesn't guarantee the presence of life, cautions Ed Turner, an astrophysicist at Princeton University. Proxima B could be like Venus, with a thick atmosphere that is significantly denser than Earth's, and extreme temperatures that would make it impossible for life to exist. The journey to unravel the mysteries of Proxima B is not without its challenges. While the James Webb Telescope holds promise, there are other factors to consider. With cost mounting, space scientists are feeling the pressure to find ways to observe planets like Proxima B. Much is at stake, but the rewards are even greater. The opportunity to explore the unknown, to uncover the secrets of a distant planet that holds the potential for life, is a pursuit worth chasing. If the exoplanet were habitable, might we one day visit it? It's the closest exoplanet to us, which makes it so intriguing, practically like exploring our own backyard. Even more exciting is that it's roughly the same size as Earth, and its position in the habitable zone suggests it could indeed have conditions suitable for life. Proxima B's proximity also makes it an ideal target for our quest for life beyond Earth. With it being so close, it's a prime candidate for interstellar missions. Think about exploring this Earth-like exoplanet. Although we can't yet go there, it's certainly on the radar for future missions. As technology advances, it's one of the most exciting endeavors in the field of space exploration. However, it's no easy task. It would take 75,000 years for spacecraft like Voyager 2 to reach the Proxima Centauri system. Nonetheless, a solution has been proposed: solar sails. These ultra-thin sails could be used to propel a spacecraft to the Alpha Centauri system and Proxima. Along with it, this technology uses solar pressure to keep the spacecraft on course, eliminating the problem of running out of fuel. And here's something even cooler: this cutting-edge technology could provide insights into the possibility of life on other planets like Proxima B. However, like anything ambitious, there are limitations. For instance, the presence of an atmosphere doesn't necessarily guarantee the presence of life. Proxima B could be like Venus, with a thick, hot atmosphere that's inhospitable. Furthermore, get this, the James Webb Telescope can detect such emissions if it reaches a brightness of only 5% of the daytime side. Now, 5% may not seem like much, but when dealing with a star that's generally dimmer than our own sun, it's quite significant. If Proxima B has advanced civilizations, they may use bright orbital mirrors to reflect sunlight from the daytime side to the nighttime side. How cool is that? There are countless exoplanets waiting to be discovered in our universe. These planets come in all shapes and sizes, with some being gigantic gas giants, while others resemble our own Earth. But what do we know about them? One type of exoplanet that has caught the attention of space scientists is the gas giant. These planets are similar in composition to Jupiter and Saturn but are much larger. Some of these behemoths have been named super Jupiters, surpassing even the largest planet in our solar system. Yet that's not all. There are also hot Jupiter's gas giants that orbit extremely close to their host star, existing in a scorching world with temperatures that could melt metal. Imagine seeing such a planet up close with its furious storms and extreme heat. In addition to gas giants, there are also Neptunian exoplanets which are similar in size to Uranus and Neptune. Among these are the hot Neptunes and small Neptunes, which are smaller and closer to their host stars than their gas giant cousins. These planets are often shrouded in mystery, with their atmospheres being difficult to study from a distance. And let's not forget the Earth-like exoplanets which resemble our own Earth. These planets come in various sizes, ranging from smaller than our planet to twice its size. There are even super Earths which have masses more than twice that of our planet but are lighter than Neptune. One of the most captivating exoplanets recently discovered is Proxima Centauri B, which orbits the star of the same name. This planet is classified as a super-Earth with an estimated mass of 7 Earth masses. Although it is close to its host star, it is still too far away to be considered within the habitable zone. Proxima Centauri B isn't alone. It has a companion, Proxima Centauri C, which is much farther from the star. This planet has an orbital period of around 5 Earth years and was discovered in 2020 using pre-recovery Hubble data. What's even more interesting about Proxima Centauri is that it appears to be an incredibly bright world, possibly due to the presence of a ring system. There's more to uncover in the Proxima Centauri system. In 2019, astronomers detected a shift in the star's orbital speed, which could be the result of another planetary companion. If confirmed, this planet will be called Proxima Centauri D and will be roughly the size of Mercury or Mars. Imagine a life where the night sky is filled with stars as well as countless other planets, each with its own unique characteristics, and orbits. The universe is full of surprises, and exoplanets are just one of them, with new discoveries being made constantly. It's an exciting time to be a space scientist. While we don't yet have an accurate count of exoplanets, we do know they exist, just as we know the stars that light up the universe. However, exoplanets are not without their challenges. They are often hidden by the glare of their host stars, making them difficult to study. Still, with advancements in technology, direct imaging of exoplanets is now possible. For an exoplanet to be directly imaged, it must be large enough to be seen by the telescope, far enough from its host star to avoid being obscured, and young enough to be hot and visible from Earth. These requirements limit the number of exoplanets that can be directly imaged, but they provide a fast-inting glimpse into the attributes and composition of these distant worlds. Exoplanets are most commonly found through the changes they induce in their host stars. The gravitational pull of an exoplanet can cause its host star to wobble, and this radial velocity can be detected by astronomers. The Kepler Space Telescope used the transit method, which measures the dimming of a star's light when an exoplanet passes in front of it. This method has provided valuable information about exoplanets, including their size, distance, and temperature. Here are a couple of fun facts. Did you know that more than 22% of stars like the Sun have Earth-sized planets in their habitable zones, or that TRAPPIST-1 is home to 7 rocky exoplanets with water on their surfaces. Exoplanets like those in our solar system can also have natural satellites known as exomoons with more than 4,000 exoplanets discovered so far. We know they exist in abundance throughout the universe. Hot Jupiters, with their mass and rapid rotation, are the easiest to find, but countless other exoplanets remain to be discovered. NASA's James Webb Telescope is unveiling the secrets of the universe, one discovery at a time. This extraordinary telescope has been gathering data and capturing stunning images of the universe, revealing previously unknown wonders. Recently, it made a groundbreaking discovery that will change our understanding of the universe forever. NASA announced that the James Webb Space Telescope has found the first definitive evidence of carbon dioxide in the atmosphere of a planet outside our solar system. This discovery provides crucial insights into the planet's composition and formation, offering us a glimpse into the mysteries of the universe. This gas giant planet orbits a sun-like star 700 light-years away, and this finding marks a significant step forward in the search for extraterrestrial life. NASA Administrator Bill Nelson stated that this discovery would provide us with a new perspective on the universe that we've never seen before, sparking excitement among astronomers and scientists worldwide. But that's not all. The James Webb Space Telescope has been busy capturing breathtaking images and gathering data about the universe in the infrared. The light from the young emitting object, known as 110 IROS 4, illuminates the cool, wispy cloud material, and the orange spots behind the cloud reveal light from distant stars obscured by the ice in the cloud. This remarkable research was part of Webb's Ice Age project, which aims to study the formation of ice from its creation to the development of icy comets. And that's not all. The James Webb Space Telescope has imaged the inner workings of a dusty disk surrounding a nearby red dwarf star, capturing it for the first time at these light frequencies in the infrared.